Okay, another off the cuff here on the amp mods. Alright. Okay. Let's see. One thing has changed in this circuit view since the last video, and that's just that I'm just using one cap here now. I decided 0.33 microfarad would be adequate for a snubber. And today I did pull down the amp, and I took this out, and I took this out, and I took this out. So, and like I said, this only drops the voltage. It drops the screen and preamp voltage to about 0.73 volts lower than 270, 269 something. It's not that much. It's actually, it's just chewing up power. And before I did that mod, the power transformer would get hot because I'm running it full crank, and I'm boosting into it, and my overdrive is actually happening in the power tube, and the output transformer would get hot. Before, when I was just testing the single speaker at 8 ohms, the output transformer got hot here also. So I did go to 16 ohms with the 2 speakers, and then after that, the output transformer ran cool, but the power transformer was still running hot. I did this mod where I'm jumpering this. This is only coming up from 269 volts point something to 270. Okay, so it's basically inconsequential. So this is jumpered. The mod I did today, I jumpered this. I pulled this, and I pulled this, and I didn't have the snubber cap to put in there. I didn't have any 400 volt snubber cap anything to put in there yet, so because I wanted to order everything all at once. So I pulled it down to just check some values and stuff. So this is basically just running straight through and down, and there's no anything in there other than that. It's just the connections to the, you know, the grid stopper or the screen stopper, and to the 2 plate resistors. And the output transformer, after thrashing on it for I don't know how long, is at least an hour, long enough to where it would be hot. It wasn't hot. Okay, so that's good, because if my power transformer windings are cooler, then the resistance, see, when a wire heats up, the resistance increases, which would drop the voltage here. It wouldn't be the textbook 270 showing up when you're you know, you're boosting into your amp and you're getting your overdrive in your power tube. This would probably drop to 260 or something just from the heat in the transformer. Okay, so this is going to be louder. It's going, for that reason, by itself, it's going to be louder. And then because the tone stack mod is going to be filtering out a lot of that out of band flub, like below your fundamental, like if you hit your fundamental note and you look at the fundamental, you know, on a fast Fourier type real-time thing, you get all this low end flub that's out of band. You know, you can't stop that from happening. It's like it's kind of connected to those frequencies in some way, and it just kind of flubs, you know. And you take that out, and it increases the amp headroom, so that's going to make it louder also. It gives me more headroom. That means it's going to be louder. So this was a good move here, because that, and then really the main reason I did that initially was because I needed to get more current through here to drive the tone stack. And then of course those get swapped out, so that, and then I think they made a mistake there. When I looked into it, I say that it's not in the other video. I actually wrote it in the description of the other video, where it's like, how much you want to bet those guys got that mixed up somehow? Because this is a higher impedance load here, and this is a lower impedance load, and this is set up to be a high gain, high impedance, or no, this is set up to be a low gain, low impedance, and this is set up to be a high gain, high impedance driving a low impedance load, and a higher gain, or a lower gain, sorry. No, this is the higher gain. This is the higher gain, high impedance. This is the lower gain, low impedance. That's how they have it set up, and this is a higher impedance load than this is. So I think somehow they got these mixed up. So this 120K's got to be over here, and this 100K's got to be over here, and well, I'm just getting new resistors, and the same thing with the cathode resistors. They get swapped. So that this is high gain, high impedance driving the high impedance load, and this is low gain, low impedance driving the low impedance load. I think it was just I don't know how stuff like that happens, but it does. You know, if it's a bunch of people working in a work group, somehow they got mixed up there. So I caught that one, and then two, this is kind of like based on, I don't know, a lot of input sections you see that are the old vintage with the two inputs on there. You know, and they, I think, didn't realize, or that when you plug into the high input, there's a switch on the jack that basically, you know, they're hooked together is what it is, and there's two 68Ks in parallel when you're in the high input, and the 1 meg here. So, you know, half of 68 is 34, so I took it to a 33K. That's a standard value, so I'll get a little bit more heat here, and then this is going to be the high gain, high impedance triode, and this is going to be the lower gain, lower impedance triode. Okay, so now I went through the tone stack mods in the other video. That's just these 3 caps and that resistor. Oh, and I did jumper past this. I thought, well, I'm gonna run my mid kind of cranked anyways, so I took this out, and you know, it gave it a little bit. It's a little bit hotter, but you know, there's more voltage too. Now I got to talk about the power supply, and that's primarily why I'm doing another video here. Okay, but anyways, it's going to be a 1 snubber cap deal, and I got that in the. I'll put the mods, consolidated mods, in the description on this video. Without all the clutter, it'll just be clean cut mods on this Oa-H05. Anyways, the one thing I forgot to say in the other video on the tone stack, now that I was talking about it, is that I designed it to sound, you know, it'd be a good overdriven tone when the tone stack is completely cranked. And that's the reason I did that, is because this is just a single 12AX7 preamp. Okay, so and it is a very, very efficient tone stack. It's much more efficient than the stock one. You know, some places it's like 7-8 dB more getting through it, so it's a lot hotter, and you know, but see, you got your master volume right here, and that's the whole thing. There's a gain control here, there's a master volume here. Yeah, it's going in a lot hotter, but you know, if somebody wants to wants the overdrive happening in the preamp section, they can crank the gain and turn down the volume. If somebody wants the overdrive happening in the power section, they can crank the volume and turn down the gain. Or any mix and match, you could get it breaking up here a little bit and have it breaking up here a little bit, depending on how you adjust the gain and the volume knobs. And I think to me that seems correct. You should be able to overdrive the power amp section if you want to. That's how I think about it. That's how I went at it. Okay, so now I'm going into the power supply mod. And this is a schematic that was not in the other video. This, as I said though in the other video, this power supply is absolutely brilliant. I actually modeled the filter in Spice because I couldn't understand this section here, and they explained it to me. Well, here I could show the thing that they put here. It's a bipolar junction transistor filter. Okay, this section here, and what that does is it's basically like they designed a solid state inductor. It basically does what an inductor would do. This is like a pi filter here, you know, and then that's feeding into this. It like responds to the ripple voltage here, and that affects the ripple shows up at the gate, you know, because the cap is going to fill to like a ripple RMS, you know, and it kind of shows up like that, but there's this thing where it, like when the ripple goes high here, it's opening the gate and the current is flowing through. And then when the ripple goes low here, it's the capacitor is discharging through the base and out the emitter. And what you get here is friggin' unbelievably smooth. It's really good, but I was playing with this because I wanted more sag. And when I did the mods today, I did a test mod, basically a sag test mod. And I pulled C13 right here. I pulled this one out. Okay, and I got a little more sag, but I did notice a little bit of 120 cycle. Just very, very faint, some 120 cycle. And that's why I went into Spice with it. And I modeled it in Spice. And I put all the capacitors in there as designed at 22 microfarad, and it was just beautiful, just unbelievable, smooth as glass, just beautiful. This is only 22 ohm resistor, and this is basically like a variable resistor that's acting like a choke. And but there's the DCR is like nothing when it needs to be nothing, and there is a DCR when, you know, when the capacitor is discharging, but then the power's stored and released this way during ripple low. Okay, so that's okay that the DCR is higher here because it's the base to emitter that's filling it in. I mean, it's just really, it's absolutely stunning. And then these are solid state diodes, and then if you think about this, how small this amp is, this is how they did it. They, instead of, like if you had a regular tube transformer, you'd have a center tap, and that you'd have one side from center tap to one side conducting, and then the other side from center tap, you know, conducting. Okay, well, that would make for a bigger transformer. What they did is they were able to use a smaller, more compact power transformer because they took these two silicon diodes and turned the combination of the silicon diodes and the valve rectifier into a full wave bridge rectifier. And I thought that that was another thing that was just absolutely brilliant. You know, really, really good. Anyways, when I was in Spice and I modeled this, I was pretty impressed with it. But then I took this capacitor out like I did in the mod, and not this one here. I took this one out like I did in the mod. It doesn't matter, they're in parallel. I took one of them out, and this did not perform optimally. As soon as I put that capacitor back in, this was operating perfectly. I was like, I don't know how they did this. These guys are smart. They're not jokers. I mean, they kind of screwed up the tone stack, but these guys know what they're doing. This is a friggin' excellent supply. So anyways, I took all these 22 microfarad caps in Spice. I took them down to 10 microfarads. And it performed just as beautifully as it did with 22 microfarads on all of them. So it's just the evenness translates. And then this is operating at an optimum with 10 microfarads all the way across. Well, I took out 22 microfarads, and I started getting like this sense of sag that was like, well, that's almost there, but I felt like, if I could just take out one more cap, I would be there with the sag. And I don't like super squishy sag. Like I don't like I know what I like in sag, but it's not the yellow tweed sponges. It's more, I don't know how to explain what I like in sag. It's like somewhere between an EZ91 and a 5U4GB. That's the kind of sag I like, and I think that's what most people like. Like those Hughes and Kettner stomp mans, the middle with the sag control straight up and down. That's the kind of sag I like, and that's the kind of sag most people like, and that's why they put it in the middle. That's the middle of the control. You go the one way, you go more towards the 5AR4 and silicon diodes, and you go clockwise and you go more towards the tweed sponge thing, but it's still, I think my taste in sag is middle of the road. So anyways, I was thinking I wish I could take another capacitor out of there, but it says I know it won't work at all if I do that, because I'd be eliminating the pi or eliminating the catch on this side of this. I can't take that out of there, well. So I put it in Spice, and it works. It works just as good at 22 across the board as it does 10 across the board. So that ended up being like, well, that's where it needs to be. And then I found those caps with the 7.5 millimeter spacing that were shorter, and there is a pinch point on C13 with the power transformer secondary leads coming out into the chassis. There's a pinch point with C13. Well, with the 10 microfarad, it's shorter. It's shorter, so there's more room for it to get through there. So anyways, that's the other mod. Okay, so there was some post video mods, and this is one of them, is the Sag mod, and that's a middle of the road, middle of the road-ish sag. If some people don't like sag, people that want a really percussive attack and really, like a lot of metal guys, they want silicon diodes. Some people like the punchiness of pure silicon diodes. Well, this is source resistance. It all depends on the source resistance. And this is the 64. It's going to have dynamic valve rectifier type source resistance, and then these are just adding like a linear silicon diode source resistance to that. So there is some source resistance there. I just had to tap into it. And the experiment I did by removing C13, that was the way to go was with that Nichicon cap. Okay, so now I guess we're back to, okay, so the post other video mods was the Sag mod that I just talked about, and swapping these guys around. I was talking about making this 100K, making it just like this triode, making this one, and then I realized that, hey, you know what, this is a lower impedance here, and I need more gain over here. And then I did the 33K, and that's about it. Otherwise, you know, anyways, I'll put the full mods in the description here. I did talk to Ori Pure about it. Well, IKN Music. I talked to IKN Music about it, and I don't know if they're gonna do it or not. If they do, try my mods. I would guess they're gonna put those into production, because it's, you know, you just get a guitarist's ears, you know, on some finer points with this. And it's like I said, you know, if it's not like I'm changing the entire amplifier, it's still gonna be similar, you know, but it's a lot more refined. And the thing is you just tweak one value and you got to change it. You know, you just do, it's a whole bunch of little tweaks. It's not anything drastic, you know, it's just a bunch of little tweaks. But you tweak the value of something and you got to pull out the stock one and put in a new one. And that's why it looks like a lot of mods, but it's really, I mean, it's going to total up to, you know, the mods altogether are gonna be like, well, to a guitarist's ears, that's like mega. That's freaking, that's the gold, you know. But it's really not that much. It's just little tweaks. It's a bunch of little tweaks, just refinements, you know. I don't know. I think, you know, people got to make money. They have to have something rolling. As they're designing this, they're having money, they're investing money in the design and the development process, and I know I can just see it. It's like, we got to get this thing out there, we got to get this done so that we start getting some returns. And I think I did a really good job, and I know I did a really good job. I know I did. I don't just think I did. I know I did, and I haven't even played through it yet, but I know it's gonna sound amazing, and it is gonna be louder, and it's gonna be a little more flexible, and the tone stack is gonna sound more correct, instead of having that sub Fender notch, which is kind of it's not bad. It just doesn't really match up with, you know, a guitar's standard lump. What the guitars put out, that's what you gotta suppress. That's what the mids have to suppress, is that lump that pickups put out. But like I said, they probably, you know, when you're designing something and you got a team working on it, you're paying people, like whoever they paid to do this power supply, it's, you know, they were worth every penny. Every single penny. But I don't think they quite understood the Sag thing. They were more like, I have to cover the amount of current, you know, all the current this could potentially draw, and then some to make sure that the ripple is there's no ripple at all. Well, we put up with a little bit of ripple. Guitars put up with a little 120 ripple, because it's just the transient of the signal is the hardest part of the signal to compress. That's why Sag is so convenient. It just smashes that transient spike, and your notes sound softer. You know, you can play louder and it doesn't hurt people's ears. So it's you know, and some people, you know, it's like, well, I'm so distorted that it's just annihilating the transient peak. But if you play mild overdrive, you know, and I'm kind of, you know, with these speakers, I should mention that the speakers too on this prototype that I made, high-powered speakers, I figured out, I learned what it is about high-powered speakers, and what it is that the speakers are so clean. They are so clean that you just twist the gain more on your amp, because there's no cone breakup, there's no cone modes, there's no, I mean, it's just very, very clean sounding speakers. And you end up like trying to get your tone, and you end up in a more gained situation than you normally do. Like me, I play, you know, if I had like an amp that was matched up with some speakers that went into breakup, where I like it to go into breakup in proportion to my gain, I wouldn't be running anywhere near as much gain as I am with these high powered speakers. You know, and I guess that's the thing, is you kind of, it's about the breakup in the tubes and the amplifier sound. It's not so much about the speakers. But you do end up, I did end up gaining up more than I normally would. Like normally I'd run, I don't know, what most people would call mild to mid overdrive, but you know, I run it solid mid-level overdrive. Like I'm overdriving it. I'm definitely in it overdriven, but you know, it's like it's not better or worse, it's just different. It's just a different kind of sound, and I don't mind it. I kind of like it. I'm into it now. So but you know, this amp and these amp mods, you know, this is a head. It's a head amp. You can put it on any speaker you want. But you know, I'd suggest the mods, and I would suggest a 16 ohm load, because your tranny is just going to run cooler. You know, the output transformer. And then if you're not really pounding the amp as hard, maybe you don't need to do the mods if you can stand the tone stack. You know, because that's what these mods are all about. Is, well, and Sag. You know, so maybe somebody wants to do the Sag mod and they don't want to do the rest of the mods because they play more clean, or they run speakers that break up more, and then you don't have to get so much drive into it. You know, it's, I guess I could think of the Sag mods separately as the other mods, but the tone stack is more British. It depends on if people like this tone stack or not, but it really, honestly, the mid is just on the low side of a pickup lump, and it's just kind of pushing down here and bulging up this one way, and I don't know, to me it sounded off. And then when I analyzed it, I realized it wasn't me. It's not me. That's, you know, anything south of Fender is, that's too low. So I brought it up, and I talked about that in the other video. Anyways, I'm gonna make a long video as short as possible here and wrap this up.